In this video, I'm going to do the Paper 1 higher tier from May 2018. Okay, so question 1. Work out 2 1/7 plus 1 1/4. So the first thing I'm going to do is I'm going to make these top-heavy fractions. So I'm going to change 2 1/7 into 2. So when I've got 2, I've got 2 lots of 7/7. So 2 7s is 14, and I've got 1/7, so that's 15/7. Every 7 makes a whole, so I've got 2 7s, which makes 14. That's 2 whole ones, and 1 more. And the same with 1 1/4. A whole one is 4 quarters, plus 1/4 is 5 quarters. The next step is going to be to make the denominators the same, make the bottom numbers the same. And I'm going to do that by multiplying 15/7 by 4 and 5 quarters by 7. So that should make the bottom numbers the same. 4 15s are 60. 4 times 7 is 28. 5 7s are 35. And 4 times 7 is, of course, 28. So now I've made the denominators the same. So I'm adding the same thing. I'm adding 28s. I've got 60 of them, plus 35 of them. So I've got 95 28s. The question doesn't say simplify your answer or give your answer in a certain form. So 95 28s is our answer. Part B. Work out 1 1/5 divided by 3 quarters. And it says give your answer as a mixed number in its simplest form. So we're dividing fractions this time. And the first step is going to be the same as before. We're going to make this into a top heavy. So I've got 1 whole one. We're in fifths. So a whole one is 5/5 plus 1/5. So that's 6/5. Divided by 3 quarters. To divide fractions, I'm going to change it to a times and flip over the second fraction. So dividing by 3 quarters is the same as timesing by 4/3. And then I'm just going to times the top times the bottom. So 4 times 6 is 24. 5 times 3 is 15. And I'm going to simplify this. So they're both in the 3 times table. I've got 24 is 3 times 8, and 15 is 3 times 5. So I've got 8/5. I need to give it as a mixed number. So how many whole ones have I got? A whole one is 5. So I've got 1 whole one, and I've got 5/5, and I've got another 3/5. So I've got 1 3/5. Question 2. In a village, the number of houses and the number of flats are in the ratio 7:4. Houses to flats, 7:4. The number of flats to bungalows is 8:5. There are 50 bungalows in the village. How many houses are there? So if there are 50 bungalows, that means we're timesing by 10 here. So there must be 80 flats. If there are 50 bungalows, there are 80 flats. And if there are 80 flats, what do you times 4 by to get 80? That's 20. So we times 7 by 20 as well, which is 140. So there are 140 houses. Question 3. Renee buys 5 kilograms of sweets to sell. She pays £10 for the sweets. She's got 5 kilograms, 10 pounds. She puts all of the sweets into bags and 250 grams into each bag. So 5 kilograms is 5,000 grams. So how many bags has she got? She's got 5,000. How many 250s make 5,000? So how many 25s make 500? 4 25s make 100. 4 times 5 is 20. So 20 bags. She's got 20 bags of sweets. She sells each bag for 65p. So it's 65p times 20. So how much does she sell them for? Put p there so we know. So 65 times 2 is 130 times 10 is 1,300. So she sells them for 1,300p, which is £13. So she paid £10 for the sweets. She sold them for £13. Work out her percentage profit. So percentage profit is like percentage change. It's the change. So how much it's gone up by, divided by the original, and times 100. So how much has it gone up by? It's gone from 10 to 13. So it's gone up by 3. Over the original, which is 10, times 100. So 3 over 10 is 0.3 times 100, that's 30. So 30% profit. It's gone up by 30%. Question 4. A cycle race across America is 3,069.25 miles in length. Juan knows his average speed for his previous races is 15.12 miles per hour, and for the next race across America, he's going to cycle for 8 hours a day. Estimate how many days Juan will take to complete the race. So we've got a non-calculator paper. It's saying estimate. So we're going to round these numbers. We can't work out with the exact numbers, so we're going to round them to numbers that we can calculate with. So we've got 3,069.25. We can call that 3,000. And 15.12. We can call it 15. You could call it 20 and say one significant figure. I think 15 will be easy enough to calculate with, and it's more accurate. So I'll go with 15. You could use 20. And 8 is fine. We can use 8. So estimate how many days he's going to take to complete the race. So 15 miles per hour, 8 hours a day. So 15 times 8 is how many miles a day he's going to do. So 15 times 8. 10 8s are 80. 5 8s are 40. So it's 120 miles per day. He's got 3,000 miles to do. So how many days? How many 120s make 3,000? So how many 12s make 300? By half top and bottom, that's 150 over 6. Half again, 75 over 3. And 75 divided by 3 is 25. So it will take him approximately 25 days. Part B. Juan trains for the race. The average speed he can cycle increases. It is now 16.27 miles per hour. How does this affect your answer to part A? So there's two different ways we can answer this. We can say if he's faster, it will take him less days, take him fewer days. So if he increases speed, it will take less time. Or we could also say, another perfectly good answer, is it wouldn't change my answer because I'll still round to the same thing. So you could put, I would still round to 15. My answer wouldn't change. Either of those two are perfectly acceptable answers. Question 5. Here is a solid square-based pyramid VABCD. The base of the pyramid is a square of side 6. The height is 4. And M is the midpoint of BC. And V to M, so the diagonal height, is 5. Draw an accurate front elevation of the pyramid from the direction of the arrow. So if we're standing here, looking at the pyramid, it looks like a triangle from the front. So it's 6 along the base, and it's 4 centimeters tall. So we will be able to see a triangle, 6 along the base, 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4 centimeters tall. So that is how the shape will look standing in from the front. Part B says, work out the total surface area of the pyramid. So the total surface area is the area of every surface added up. So we have a square, and we've got 4 of these triangles. So we've got a square, which is 6 by 6, and we've got 4 triangles, 4 of these triangles, and they've got a base of 6 and a height. The height of the triangle is 5. So we've got a base of 6 and a perpendicular height of 5. So the area of the square is 6 times 6, which is 36 centimeters squared. And the area of a triangle is base times height divided by 2. So base times height divided by 2. 6 times 5 is 30. Half of that is 15. So 15 centimeters squared. And remember, we've got 4 of those, 4 of these. So I've got 4 15s. To multiply by 4, double it and double it again. So 60 centimeters squared. So I've got 36 plus 60. And that is 96 centimeters squared. There was no units given to us in the box, so we need to write them in. So 96 centimeters squared. We measure area in squares. Question 6. A pattern is made from 4 identical squares. The sides of the squares are parallel to the axes, and it's told us the coordinates of point A, which is shown on the diagram, the coordinates of B, again shown on the diagram, and we've got part C marked on the diagram, and we need to know the coordinates of C. So if we look along the x-axis, the difference between our 2 points along the x-axis is 1, 2, 3, 4 squares. So all 4 squares, so the length of the side of all 4 squares, 4 lengths of a square are the difference in the x's. So the x's were 38 and 6. So the difference in the x's, 38 take away 6, is 32. So that distance from A to B is 32, and that represents 4 squares. So 32 divided by 4, half it, so to divide by 4, half the number and half it again. So 32 divided by 2 is 16, divided by 2 again is 8. So that means each length of a square must be 8. And because it's a square, the heights must also be 8. And we can now work out where C is, because if we look at start at B, we go back 2 squares, so that would be 16 back, 16 down the y-axis, and 16 back along the x-axis. So we're going to take 16 away from B's coordinates, and that will tell us where C is. So we've got 38 take away 16 for the x-coordinate, which is 22, and 36 take away 16 for the y-coordinate, which is 20. So we're at 22, 20. Question 7. So we've got a shape drawn on our grid. Shape T is reflected in the line x equals -1 to give shape R. Shape T is reflected in the line x equals -1 to give shape R. So x equals -1. This is x equals -1, this line here, where x is -1, x is -1 all the way across this line, and we're going to reflect it, so it's 2 away, this bottom corner is 2 away from the line, so it'll be 2 away on the other side. The bottom right corner is 4 away, so it's going to be 4 away on the other side of the line, and the top point is 3 away, so 1, 2, 3. So that makes shape R. And then shape R is now reflected in the line y equals -2 to give shape S. So y equals -2, that's here. So we take the bottom corner first, 1, 2, 3, 1, 2, 3. Bottom right, 1, 2, 3, 1, 2, 3. And the top, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So that's shape S. Describe the single transformation that will map shape T, so our original shape, onto S. So how would you get from T to S in one transformation? So that will be a rotation of 180 degrees about 1 minus 2. So it's a rotation of 180 degrees about -1 minus 2. So if we held the tracing paper at this point and span our shape around, we would get from T to S. Question 8. The perimeter of a right-angled triangle is 72 centimeters. The lengths of its sides are in the ratio 3 to 4 to 5. Work out the area of the triangle. So we've got 3 parts, 4 parts, and 5 parts. 3 plus 4 plus 5 is 12. So we've got 12 parts in total. So we're going to share our 72 centimeters out between the 12 parts. (72) divided by 12, that is 6. So we've got 3 times 6, which is 18, 4 times 6, which is 24, and 5 times 6, which is 30. So we've got a right angle triangle with the biggest length, so the hypotenuse is 30, and we've got 24 and 18. And the question says, work out the area of the triangle. So the area of the triangle, is half base times height, or base times height, divided by 2. So half times 18 times 24. We use the perpendicular height. We don't use the diagonal height. We use the perpendicular height to work out the area of a triangle. So it's half times 18 times 24. Half of 18 is 9, so 9 times 24. 10 times 24 is 240. Take away 124, that's 216, and it's centimeters squared. Question 9. Write down the value of 36 to the power of a half. Power of a half means square root. So the square root of 36 is 6. Part B, write down the value of 23 to the power of 0. Anything to the power of 0 is 1. So 23 to the power of 0 is 1. And part C, work out the value of 27 to the power of minus 2/3. So the 3 on the bottom, the thirds, that's a cube root. A 2 means square, and the minus means the reciprocal, or flip it over. So we're going to cube root 27 is 3. Then we're going to square it, so 3 squared is 9, and then we're going to flip it over, so we get 1/9. Question 10. The table gives some information about the heights of 80 girls. So we've got the least height, the lowest, the biggest, the lower quartile, the upper quartile, and the median. That is the exact information we need to draw a box plot, and we're being asked to draw a box plot. So we don't need to work anything out. We just need to draw these lines onto our box plot. So 133, 170, 145, 157, and 151. And there's our box plot. Part B. Work out an estimate for the number of these girls with a height between 133 and 157. So 133, that was our lowest point. 157, that's our upper quartile. And well, what a box plot does is it splits the data into quarters. So a quarter of the people should be between the lower and upper, the lowest and the lower quartile. A quarter of the people between the median and the lower quartile, and another quarter of the people between the median and the upper quartile. So this should be 3/4 of the people, and there are 80 people. So 3/4 of 80. So 1/4 of 80 is 20. So 3/4 is 60. Question 11. A and B are points on a circle with center O. BC is a tangent to the circle. So we know a tangent meets a radius at 90 degrees. So we've got a 90-degree angle here. And I'll write that in. So we're going to give reasons for each stage of our working. So I'll write in straight away, OBC is 90 degrees, tangent meets radius at 90 degrees. And now I'll finish reading the question. So AOC is a straight line. Angle ABO, ABO is X. Find the size of ACB, ACB. In terms of X, and we have to give reasons for each stage of our working. So we've got AO and OB are both radiuses. So we've got an isosceles triangle here. The angles at a base of an isosceles triangle are equal. So OAB must also be X. So OAB is X, and that's because the angles at the base of an isosceles triangle are equal. So we've got X and X, so that means we can work out AOB because the angles in a triangle add up to 180 degrees. So AOB is 180, take away X and X, take away 2X, because angles in a triangle add to 180 degrees. And we can now work out BOC, because angles in a straight line add up to 180. So BOC is 180 minus 180 minus 2x. That looks confusing, but we've got 180 minus 2x. We need to add something on to get to 180. So 180 minus 2x plus something equals 180. It must be 2x. So the angle here must be 2x. 180 minus 2x plus 2x is 180. So 180 minus 180 is nothing, and minus 2x is 2x. And that is because angles on a straight line add to 180. So we've got BOC. This is 2x. We've got 90 degrees here. And again, we've got a triangle. So angles in a triangle. We're working out ACB. So ACB is 180. Take away 90. Take away 2x. 180 take away 90 is 90. So it's just 90 minus 2x. That's our answer. And angles in a triangle add to 180. Question 12. Prove that the square of an odd number is always one more than a multiple of 4. So we need to use algebra for this. And when we're using algebra, we say an even number is 2n. An even number is the 2 times table. And to get an odd number, we can either add 1 or take 1 off of the 2 times table. So the odd numbers are either 1 more or 1 less than the even numbers. So if I call my odd number 2n minus 1. So there's my odd number. I need to prove that the square of it, so this squared, is always 1 more than a multiple of 4. So how can I rearrange this to show it's 1 more than the multiple of 4? So if I expand the brackets, I've got double brackets, 2n minus 1 times 2n minus 1. I'm going to expand them, so 2n times 2n is 4n squared. 2n times minus 1 is minus 2n. Minus 1 times 2n is minus 2n. And minus 1 times minus 1, a negative times a negative is a positive. So that makes plus 1. And simplifying, I've got 4n squared minus 2n, which is minus 4n plus 1. So I need to prove that it's always 1 more than a multiple of 4. I can factorize 4 out of the first 2 terms. 4, I've got n squared minus 4 plus 1. So this is 4 times something. So this is a multiple of 4. Something times by 4 is a multiple of 4. And I'm adding 1. So it's 1 more. 1 more than a multiple of 4. I'm adding 1 to a multiple of 4. Question 13. So I've got root 5 into root 8 plus root 18. And they're saying it can be written in the form a root 10. Find the value of a. So simplify. We need to simplify root 5 into root 8 plus root 18. So the first thing I want to do, I'm going to simplify root 8 and root 18. So root 8 can be simplified. It's got a square number in it. It's root 4 times root 2. And root 4 is 2. So root 8 is 2 root 2. And root 18 can also be simplified. It's got root 9 in it. So root 9 times root 2. Root 9 is 3. So it's 3 root 2. So we've got root 5 times 2 root 2 plus 3 root 2. 2 root 2 and 3 root 2 can be added together to make 5 root 2. So we've got root 5 times 5 root 2. And root 5 times 5 root 2, we just times the roots together. So 5 times 2 is 10. So the answer is 5 root 10. So A is 5. Question 14. Y is inversely proportional to d squared. Okay, so y equals k divide d squared. So when something's inversely proportional, it's equal to k divided by that thing. So y is inversely proportional to d squared means y is proportional to 1 over d squared, which means y equals k over d squared. And we're told when d is 10, y is 4, so we can work out k. So y is 4, d is 10, so 4 equals k over 10 squared. 10 squared is 100. So I've got 4 equals k over 100. And if I multiply both sides by 100, that will tell me k is 400. So I can change my formula up here into y equals 400 over d squared. Okay, we're also told d is directly proportional. So d is proportional to x squared, which means d is k times x squared. When x is 2, d is 24. 24 equals k times 2 squared. 2 squared is 4, so 24 is equal to 4k, and divide both sides by 4. That means k is 6. So d, I can change my formula to d equals 6x squared. Okay, what's the question say? Write a formula for y in terms of x. So I need to have a formula that's y equals, but without d's, with x's instead. So I'm going to change this d. I'm going to substitute in for d 6x squared. 6x squared is equal to d, so I can change d to 6x squared. So let's do that. Y equals 400 over 6x squared squared. So y is 400. 6 squared is 36. And x squared squared, x squared times x squared, is x to the power of 4. I need to give my answer in its simplest form, so I need to simplify these numbers. If I half top and bottom, that's 200 over 18x to the power of 4. And half them again, 100 over 9x to the power of 4. So 109 are not in the same times tables. 9's only in the 3 times table, and 100 isn't in the 3 times table. So I can't simplify that anymore. So my answer is y equals 100 over 9x to the power of 4. Question 15a. Factorize a squared minus b squared. So hopefully you recognize this as the difference of two squares. So it's like the ones where we have x squared minus 4. We've got two things squared. That goes to x plus 2, x minus 2. So this is a squared and b squared. So that goes to a plus b and a minus b. A plus b, a minus b. Part B, hence or otherwise. So hence or otherwise, when we see these words, hence or otherwise, we know we can use our previous answer. So how can we use our previous answer? Simplify fully. X squared plus 4, all squared, minus x squared minus 2, all squared. So how do these two relate? Well, A has been changed to x squared plus 4, and b has been changed to x squared minus 2. So in our answer from our previous question, we can change a into x squared plus 4 and b into x squared minus 2. So let's give that a go and see what happens. So a is now x squared plus 4, b is now x squared minus 2. A x squared plus 4. We've got to be careful with this minus. It's taking away all of b, which is x squared minus 2. So that's going to, when we simplify it, we need to take away the x squared and take away the minus 2. So let's simplify the first bracket first. X squared and x squared makes 2x squared. And 4 minus 2 is 2. And the second bracket, x squared minus x squared is nothing. And 4 minus 2 means plus. So 4 plus 2 is 6. So I've got 6 times this bracket. If I times them by 6, that's 12x squared plus 12. Question 16. There are only red counters, blue counters, and purple counters in a bag. The ratio of the number of red counters to the number of blue counters is 3 to 17. Sam's taken at random a counter from the bag. The probability of a purple counter is 0.2. Work out the probability of red. So 0.2. So 20%, I'll call it 20%, are purple. So if 20% are purple, that means the red and the blue must be 80%. 100%, take away 20% is 80%. And we've got the ratio 3 to 17, so we're going to share 80% in the ratio 3 to 17. So I've got 3 and 17, means I've got 20 parts. So 80% divided by 20. So 4% per part. 4% per part. And I want red. So red is 3 times 4. 3 lots of 4%. 12%, or 0.12. Question 17. Simplify fully. So I've got, this is the question where we factorize the top, factorize the bottom, and cancel out the bracket that's the same in both. So I need to factorize the top and the bottom. The bottom looks a lot easier to factorize. So I'll do that first. We've got 2x squared minus 6x. 2 and 6 are both in the 2 times table. And they've both got an x in them. So I'm going to take 2x outside. 2x times x makes 2x squared. And 2x times negative 3 makes negative 6x. So I've got 2x and x minus 3. So I now need to factorize the top. So 3x squared minus 8x minus 3. I'm going to use the method where I multiply the a and the c. So because I've got a number in front of the x squared, it's not the straightforward factorizing. I'm going to do the a times c. So 3 times negative 3 is negative 9. What multiplies to make my 9? 1 times 9, or 3 and 3. And which of those can I use to make a negative 8? That's going to be plus 1 minus 9. So I'm going to put, see the number 3 in front, I'm going to put 3x over 3. And then inside the brackets, I'm going to put my +1 and my -9. I need to divide by 3. So which of these brackets can I take 3 out of? I can take it out the second bracket. So I can divide the second bracket by 3, which will cancel off my 3. So I'm going to have 3x plus 1, and the second bracket divided by 3 is x minus 3. So I've got 3x plus 1 and x minus 3. Top and bottom have both got an x minus 3, so I can cancel them off, which leaves 3x plus 1 over 2x. Question 18. Here is the graph of y equals sine x for -180 to 180. Okay, it's drawn for us. On the grid, sketched graph of y equals sine x minus 2. So we need to minus 2 from this graph. It's not inside the bracket. It's not the angle that we've minus 2 from. So it's outside the bracket. That means it changes the y and it brings it all down by 2 spaces. So we were at 0 here. We go down to minus 2. Minus 1 at minus 90. It's going to go down to minus 3. 0 at 0 goes down 2. 1 at 90 goes down 2. And our 0 at 180 goes down 2. So we just need to join these points up. So it's always 2 down from where we started. And it should look something like that. Question 19. The point P has coordinates 3, 4. Q has coordinates AB. A line perpendicular, so perpendicular to PQ, has the equation 3x plus 2y equals 7. Find an expression for B in terms of A. So what do we know about a perpendicular line? Its gradient is a negative reciprocal. Its gradient is flip and minus from our original. So if we work out the gradient of this line, flip and minus it, do the negative reciprocal, flip and minus, that should tell us the gradient of this line, which we can use in our gradient formula. So the change in y over the change in x. So let's work out the gradient first. So we've got 3x plus 2y equals 7. We want it to be in the form y equals mx plus c to get the gradient. So I need to make y the subject of the formula, get y by itself. I'm going to take away 3x from both sides. I'm going to write the 3x minus 3x in front, because that's more like the form y equals mx plus c. And then I'm going to divide everything by 2. So I'm going to half everything, half every term. So I've got y equals minus 3 over 2x plus 7 over 2. So now it's in the form y equals mx plus c. This is the gradient, so minus 3 over 2. So the perpendicular gradient, all right, m for gradient, perpendicular m is minus 3 over 2, which means the gradient is flip and minus, the negative reciprocal. So if I flip it, it goes to 2/3, and it was already minus, it was already negative, so it becomes positive. So I know my gradient is going to be 2/3. So 2/3 equals y2 minus 2/3 equals y2 minus y1 over x2 minus x1. The gradient is the change in y over the change in x. And I'll have x1, y1, x2, y2. So b minus 4, so 2/3, is equal to b minus 4 over x2a minus x1, 3. A minus 3. Okay, I just need to rearrange now. I want an expression for b in terms of a. So I want it to be b equals, make b the subject of the formula now. So I'm going to get rid of this divide by a minus 3. The opposite of dividing by a minus 3, timesing by a minus 3. So I'm going to times both sides by a minus 3. So 2/3 times a minus 3 equals b minus 4. I'm going to expand the bracket. 2/3 times a is 2/3 a. 2/3 times minus 3. 2/3 of 3 is 2. So I've got 2/3 a minus 2 equals b minus 4. I want b by itself, so I'm going to plus 4 to both sides. Minus 2 plus 4 is 2. So I've got b by itself. That's what we wanted. So I've got 2/3 a plus 2. Question 20. N is an integer, so it's a whole number, such that 3n plus 2 is less than or equal to 14, and 6n over n squared plus 5 is bigger than 1. So we've got two inequalities. We're going to solve them both, and then we're going to figure out which whole numbers work for both of the inequalities. So we're going to solve these two inequalities and then figure out which numbers work for both. Let's start with the easier one. So this is a linear one. We're just going to minus 2 from both sides. So 3n is less than or equal to 12. And then divide both sides by 3. So n is less than or equal to 4. So we now need to do the harder one. So this one's going to be a quadratic. So 6n over n squared plus 5 is bigger than 1. We need to get rid of the divide by n squared plus 5. And that means multiplying both sides by n squared plus 5. 1 times n squared plus 5 is n squared plus 5. And it is a quadratic. We've got a n squared. So to solve it, we're going to make it equal to 0. So I'm going to minus 6n from both sides. N squared minus 6n plus 5. So n squared minus 6n plus 5 is less than 0. I can solve this by factorizing. So 2 brackets, n in both. What multiplies to make 5 and adds to make a negative 6? Negative 1 and negative 5. So I'm going to draw this on a graph. So it crosses at n equals 1 and n equals 5. So it'll cross at 1 and 5. We want to know where it's less than 0. So where is this graph that I've just drawn? This sketch I've just made, where is it less than 0? That is this bit here. So the bit underneath the x-axis is less than 0. So that's between 1 and 5. So anything between 1 and 5 It can't equal 1 and 5 because it hasn't got the little line under it, the or equal to. So it can be anything between 1 and 5, not including 1 and 5. So n is bigger than 1 and less than 5. So these are our two answers. What numbers can we have that fit them? So between 1 and 5, can't be 1, so it can be 2, 3, and 4. It can't be 5. And less than or equal to 4 means it can be, well, anything less than all the way up to 4. So it can be negative as well, 0, 1, 2, 3, 4, and all the way, never ending, all the way into the negative numbers. But it's got to fit both of them. So which numbers fit both? 2, 3, and 4. So the answer, n can be 2, 3, or 4.